Yes, till now we have discussed about the system of linear equations, both homogeneous and non-homogeneous equations. So what is the procedure to solve the homogeneous, non-homogeneous equations? We have done so many questions on this, homogeneous and non-homogeneous. Now it comes to, the next topic is the characteristic matrix. Our next topic is the characteristic matrix. Characteristic matrix. So what is a characteristic matrix? What is a characteristic equation? Eigenvalues and eigenvectors. So what is a characteristic matrix here? Characteristic matrix of square matrix A. Characteristic matrix of square matrix A is what is the characteristic matrix of square matrix A is A minus lambda I. Characteristic matrix of square matrix A is A minus lambda I, where I is unit matrix. I is unit matrix of order. I is unit matrix of order same as A. I is a unit matrix of order same as A. Lambda is the parameter. What is the lambda? Lambda is parameter. Lambda is the parameter called eigenvalue. Lambda is a parameter called eigenvalue. So what is another name of this eigenvalue is called characteristic root, and also you can say latent root. So that is about the characteristic matrix. So then what is the characteristic equation? Characteristic equation is characteristic equation. Characteristic equation. What is the characteristic equation here? Yes. Characteristic equation. Determinant of A minus lambda I is equals to 0 is called the characteristic equation. If you observe the example here, lambda square minus 3 lambda plus 2 is equals to 0 is the characteristic equation. Lambda square minus 3 lambda plus 2 is equals to 0 is the characteristic equation. So what are the roots of the characteristic equation? They are called the characteristic roots and eigenvalues and latent roots. So what are the roots of this one here? Here characteristic root. Characteristic root. What is another name of this characteristic root is called eigenvalue. Eigenvalue. And also called latent root. Latent root. So what is the definition of the characteristic root, eigenvalue, latent root? The root of characteristic equation. The root of characteristic equation. The root of characteristic equation is called the characteristic root. What is another name is called latent root and also eigenvalue. In this above example, what are that? In above example, lambda is equals to 1 and 2. So in this example, lambda is equals to 1 and 2 are the eigenvalues. So what are the roots of this characteristic equation? 1 and 2 are the characteristic roots. Yes. What is another name of the characteristic root? It is called eigenvalue and also latent root. And coming to our next definition, eigenvector. Eigenvector. Another name is the latent vector. Eigenvector, latent vector, characteristic vector. Characteristic vector. Eigenvector, latent vector, characteristic vector. What is its definition is the non-trivial solution of A minus lambda I into x is equals to 0. The non-trivial solution of A minus lambda into x is equals to 0. That is called the eigenvector. What is another name of this eigenvector? Is a latent vector, characteristic vector. This x is called What is this? X is the eigenvector. X is eigenvector. So when this X is said to be eigenvector, if rank of A minus lambda I is less than number of unknowns. If rank of A minus lambda is less than number of unknowns, so then it is said to be, so X is said to be eigenvector, and also you can equate, otherwise you can say determinant of A minus lambda equal to 0. If the determinant of A minus lambda is equals to 0, then the X is said to be eigenvector, and rank of A minus lambda is less than number of unknowns, then only capital X is said to be eigenvector. So what type of equations? It is called homogeneous. This forms the homogeneous equations. This is our homogeneous. So this is a homogeneous equations. So when these homogeneous equations contains what is called infinite number of non-trivial solutions, if rank of A minus lambda is less than number of unknowns, or you can say determinant of A minus lambda equal to 0. So that is about eigenvector definition, very important. Eigenvector never be null vector. So what is eigenvector? It is a non-trivial solution. So what is the equation you can form here? Ax minus lambda ix is equals to 0. From this Ax is equals to lambda x is the correct answer. Ax is equals to lambda x is the correct answer. What is x here? X is the eigenvector. A is a square matrix A, lambda is the eigenvalue, x is the eigenvector. So that is about the eigenvalues and eigenvectors definitions, are very important. Eigenvector, if you observe here, eigenvector never be null vector. Eigenvector never be null vector. So ఎప్పుడు కూడా 0 0 0 అవ్వదు. eigenvector అనేది నాన్ ట్రివియల్ సొల్యూషన్, and eigenvector never be unique. So we have some properties of eigenvalues and eigenvectors, very important. Properties of eigenvalues and eigenvectors, they are very important. So many gate questions and competitive. Properties of eigenvalues and eigenvectors. Properties of eigenvalues and eigenvectors. So what are the different properties of eigenvalues and eigenvectors? We have, first one is the eigenvector never be null vector. Null vector means what? 0 0 0. Eigenvector, it should not be null vector. ఎప్పుడు కూడా eigenvector అనేది null vector అవ్వదు, non trivial solution. So second one, eigenvector never be unique. Eigenvector never be unique. So why eigenvector never be unique? It is a non-trivial, infinite number of non-trivial solutions. We will find infinite number of non-trivial, infinite number of non-trivial solutions. Infinite number of non-trivial solutions, that is our eigenvector. Eigenvector never be unique. Eigenvector never be null vector. Third, every eigenvector corresponds to its own, every eigenvector corresponds to its own eigenvalue. సో ఏదైనా ఐగెన్వెక్టర్ తీసుకుంటే కంపల్సరీ దాని కరస్పాండింగ్ ఐగెన్ వాల్యూ ఉంటుంది. ఎవ్రీ ఐగెన్వెక్టర్ కరస్పాండ్స్ టు ఇట్స్ ఓన్ ఐగెన్ వాల్యూ. Fourth, so here sum of the eigenvalues. What is the next? Fourth one is a sum of eigenvalues very important property. Sum of eigenvalues is equals to trace. There are so many gate questions on this property. Sum of eigenvalues is the trace. Then product of, fifth one is what? Product of eigenvalues. Product of eigenvalues is equals to determinant. Sum of eigenvalues is the trace. Product of the eigenvalues is the determinant. Sixth, So one of the eigenvalue of a singular matrix So one of the eigenvalue of the singular matrix is equals to 0. One of the eigenvalue of the singular matrix is 0. Then next, coming to seventh one, eigenvalues of non-singular matrix. Eigenvalues of non-singular matrix. Non-singular matrix are always eigenvalues of non-singular matrix are always non-zeros. They are non-zeros. Non-singular matrix means what? Determinant is not equals to 0. Singular matrix determinant equal to 0. If it is a singular matrix, definitely one eigenvalue is 0. For non-singular matrix eigenvalues are non-zeros. These are all the properties. Coming to our next property here, eighth property, eigenvalue of skew symmetric matrix of, so one of the eigenvalue, we can say one of the eigenvalues of the skew symmetric matrix of odd order is 0. Ninth, one of the eigenvalue, it becomes definitely 0 if it is a skew symmetric matrix with the odd order. Odd order means odd order ante ikkada manaki third order gaani fifth order seventh order. So అలా ఉండే స్క్యూ సిమెట్రిక్ మ్యాట్రిక్స్కి డెఫినెట్గా ఒక ఐగెన్ వాల్యూ అనేది 0 అవుతుంది. కమింగ్ టు నైన్త్ వన్, ఐగెన్ వాల్యూస్ ఆఫ్ ట్రయాంగులర్ మ్యాట్రిక్స్ diagonal matrix, eigenvalues of the triangular matrix, diagonal matrix and scalar matrix are its principal diagonal elements. So compulsory diagonal matrix gaani scalar matrix then triangular matrix iskunte eigen values anevi principal diagonal elements avutundi. All of you know what is the principal diagonal elements, sir? The element which contains aij for I is equals to j, row number column number same untavi. So coming to our 10th property, eigenvalues of real symmetric matrix and Hermitian matrix. Eigenvalues of real symmetric matrix, Hermitian matrix are always real, is also famous. There are so many gate questions on this property. Eigenvalues of the real symmetric matrix, Hermitian matrix are always real. Coming to 11th property, eigenvalues of skew symmetric matrix, skew Hermitian matrix, eigenvalues of skew symmetric, skew Hermitian matrix are either zeros or purely imaginary. eigenvalues of skew symmetric matrix, skew Hermitian matrix are either zeros or purely imaginary. So all these properties are very, very important. So coming to our next property, 12th property. If lambda is eigenvalue, if lambda is eigenvalue of matrix A, if lambda is eigenvalue of the matrix A, then 1 by lambda is eigenvalue of matrix A inverse. 1 by lambda is eigenvalue of A inverse. K lambda is eigenvalue of Ka. K lambda is eigenvalue of the Ka. Lambda power of n is eigenvalue of A power of n. A power of n. Determinant of A by lambda is eigenvalue of adjoint A. Determinant of A is determinant of A by lambda is eigenvalue of adjoint A, and lambda is also a eigenvalue of A transpose. If lambda is the eigenvalue of the A, lambda is also a eigenvalue of the A transpose. So all these properties are very, very important, and lambda plus or minus K is eigenvalue of A plus or minus Ki. A plus or minus Ki. So A plus or minus K, what are the eigenvalues here? Lambda plus or minus K. And 1 by lambda is eigenvalue of orthogonal matrix. So if A is the orthogonal matrix, 1 by lambda is also one of the eigenvalue of the orthogonal matrix. Then coming to 12th property, if X is eigenvector, if X is eigenvector of A, then X is also eigenvector of A power of n. So if X is eigenvector of the A, then X is also eigenvector of the A power of n. These are all the important properties of the eigenvalues and eigenvectors. There are so many questions in the previous competitive exams and also GATE, depends on all these properties. Remember all these properties perfectly. So coming to our numericals on these eigenvalues and eigenvectors. First one, eigenvalues of 3, 4, minus 4, minus 5 are. What are the eigenvalues of 3, 4, minus 4, minus 5 are? The solution here as follows. See how to calculate the eigenvalues of this matrix 3, 4, minus 4, minus 5. Here using the property sum of eigenvalues is equals to trace. Sum of eigenvalues is equals to trace. What is the trace of the matrix here? Trace is equals to sum of the principal diagonal elements. Trace is sum of principal diagonal elements. Principal diagonal elements. Trace is equals to sum of the principal diagonal elements. What is the trace here? 3 minus 5 minus 2. So which sum of the eigenvalues? Which sum of the eigenvalues is minus 2? Option A, sum is what here? Minus 4. It is wrong. So plus 2 minus 2, 0. This is also wrong. Minus 1 minus 1. It is a minus 2. C is the correct answer. This is also plus 1 minus 1. What is the result here? 0. So what is the property we are using here? Sum of the eigenvalues is the trace. Ikkada trace ento vachindi manaki minus 2. Which sum of the eigenvalues is the minus 2? That is our correct answer. Which option is correct here? Option C is the correct. Coming to our next bit. The eigenvalues of the matrix 4 minus 2 minus 2 1 are. Which of these options is correct here? So using the same property, the solution here as follows. Sum of eigenvalues is equals to trace. So what is the trace of this one here? Trace is equals to 4 plus 1. 4 plus 1 is the 5. 4 plus 1 is the 5. So using this property which satisfies here sum of the eigenvalues is 1 plus 4 is 5, 1 plus 2 is 3, this is wrong, option B is wrong. C, 0 plus 5 is also 5. Option A and C both are competing for this answer. Which is the correct answer out of all of them? We have to go with another property. Product of eigenvalues is determinant. Product of eigenvalues is equals to determinant. So what is the determinant of this matrix here? 4 minus 4 is equals to 0. Which product of the eigenvalues is yes, 0. Product of the eigenvalues is the determinant. Determinant is 0. Which product of the eigenvalue? 0 into 5 is 0. Which option is correct here? Option C is the correct option. Option C is the correct answer. So A is also wrong. Option C is the correct answer. Using sum of the eigenvalues equal to trace, A and C are satisfying, but using the product of the eigenvalues is the determinant. Which option is satisfying? Only C is the correct answer. So coming to our next bit. Eigenvalues of the matrix 5, 3, 2, 9. Which of these options is satisfying here? The same property, solution here as follows. Sum of the eigenvalues is the trace. Sum of eigenvalues equal to trace. So what is the trace of this one here? Trace is 5 plus 9. 14 is the trace. 5 plus 9 is the trace. Which is sum of these eigenvalues is the trace here? This is it's crossing the 14, wrong. This is also wrong, is not at all equal to. This is near about 6.5 something, and this answer is 14, and this is also a 14. But out of B and D, what is the correct answer? B and D, what is the correct answer? Sum of the eigenvalues, both B and D are satisfying. Product of, we have to go with the product of eigenvalues. Product of eigenvalues is determinant. Product of eigenvalues is equals to determinant. So what is the determinant of this one here? 45 minus 6, 39. Which product is satisfying here? 10.16 into 3.84. 10.16 into 3.84 result is the 39. Which option is correctly exactly here? D option is the correct. If you take the 9 into 5 product is 45, but we want the product, what is the determinant value here? It is a 39. Which option is equals to product of the eigenvalues is the determinant? Is option D is the correct answer. Using sum of the eigenvalues is the trace, both two options are satisfying, and using the second property, what is that? Product of the eigenvalues determinant. Which option is satisfying? Option D is the correct answer. So coming to our next bit, eigenvalues of the matrix. What are the eigenvalues of the matrix here? What type of matrix? It is a upper triangular matrix. All elements below principal diagonal are the zeros. Then what is the eigenvalues here? Eigenvalues is equals to, eigenvalues are the principal diagonal elements. Eigenvalues are principal diagonal elements. What are the principal diagonal elements? 1, 4, 3. Which option is satisfying? Option A is the correct answer. 1, 4, 3. Option A is correct. So coming to our next bit, A is a 1, 1, 1, 1, 1, 1, 1, 1, 1. Eigenvalues of the matrix are, the solution here as follows. So what is the trace of the matrix here? Trace is equals to 3. Trace is equals to 3. Which sum of the eigenvalues is the 3 here? Option A is wrong. C is also wrong. So one of the B and D. One of the B and D is a summation is what? One of the B and D is correct here. By observing it, sum of the eigenvalues is what here? The trace. So this summation is a 3. This summation is also 3. But which one is correct? To confirm the correct answer, which one is correct? We have to go with the another property. What are the properties we are using here? Sum of eigenvalues is trace. Sum of eigenvalues is equals to trace. Product of eigenvalues is the determinant. Product of eigenvalues is equals to determinant. So what is the determinant of this matrix? Determinant is equals to 0. Which product of the eigen? 0 into 0 into 3. Option B is the correct answer. What is our correct answer? Is the B option is correct here. Even using the property sum of the eigenvalues is the trace. Two options are satisfying. Which two options are satisfying? Using sum of the eigenvalues is the trace B and D. And using product of eigenvalues is the determinant. What is the correct answer? Is the B is the correct answer. So coming to our next property, next question. What are the eigenvalues of this matrix? The solution here as follows. ఇక్కడ చెక్ చేస్తే what is the trace here? Trace is equals to 6. Trace is equals to 6 and determinant is equals to 0. So using these two, which option is satisfying here? Option B is the correct answer. Determinant is equals to 0, which is equals to product of the eigenvalues. Which product of the eigenvalues is a 0 here? 0, 0, 6. Sum of the eigenvalues is 6. Product of the eigenvalues is the determinant. Option B is the correct answer. So coming to next one, consider a non-singular matrix 2 by 2 with the trace of A is 4, trace of A square is 5. Then what is the determinant of A? The solution here as follows. For 2 by 2 matrix, what are the eigenvalues? Let lambda 1, lambda 2 are eigenvalues. Let lambda 1, lambda 2 are eigenvalues. So what is the trace of A here? Trace of A is equals to lambda 1 plus lambda 2 equal to 4. And what are the eigenvalues of A square? Eigenvalues of A square. Eigenvalues of A square are lambda 1 square and lambda 2 square. If lambda 1 and lambda 2 are the eigenvalues of A, what are the eigenvalues of the A square? Lambda 1 square plus lambda 2 square. Then trace of A square. What is the trace of A square? Is a lambda 1 square plus lambda 2 square is equals to 5. Using these two formulae, lambda 1 plus lambda 2 whole square is equals to lambda 1 square plus lambda 2 square plus 2 into lambda 1 lambda 2. What is the lambda 1 plus lambda 2 here? It is a 4 square 16. Lambda 1 square plus lambda 2 square is the 5 plus 2 into lambda 1 lambda 2. From this lambda 1 lambda 2 is equals to 11 by 2. 11 by 2. What is the lambda 1 into lambda 2 is equals to product of the eigenvalues, that is equals to product of the eigenvalues. What is the property we have here? Determinant of A. Determinant of A is equals to, what is the answer for this one? Determinant of A is 11 by 2. So that is the correct answer, 11 by 2. What is the property we are using here? Sum of the eigenvalues is the trace, product of the eigenvalues is the determinant.